Okay, the next technique is called off-resonance-decoupled carbon NMR. This technique tells you the number of hydrogen on each carbon. Give you some example. Take a look. All right. So the bottom one is just a regular carbon proton decoupled. Remove the interaction between carbon and hydrogen atoms. Right. So that's why you see a nice clean carbon NMR. The top one. So we let carbon and hydrogen communicate. Let the interaction between carbon and hydrogen happen. Okay, see what happened from this peak right here. This carbon got one hydrogen on it, so they interact with each other, show up a doublet up here, two peaks. Yeah. All right, try next one. So this carbon right here got two hydrogen on it. Let this carbon and this two hydrogen interact, so we see three peaks. One more. So we have this carbon right here, three hydrogen on it, right? Three protons on it. So this signal right here, that's the red carbon proton, that carbon signal. Three proton, four signals. Basically, the number of peaks up here is the number of hydrogen plus one, right? It tells you the number of hydrogen on each carbon. The two peaks right here, double peak, so we call a doublet. Three peak, we call a triplet, and the four peak, we call a quartet. We'll come back to this later on in the proton NMR use. This because spin multiplicity is really important, especially in the proton NMR. Okay. Anyway, so it looks something like this. So CH3 so show four peaks. Okay. CH2 show three peaks. CH2 three peaks. CH two peaks, and if there's no hydrogen on it, just a singlet. All right. Let's practice with me. So you have to match signal to the spectrum. Okay. All right, let's do a pause the video first. Do on your own. Don't copy me. All right, I just want you to think first. Let's say, all right, we got carbon number 2. Obviously, it is on region number 4, so that's carbon new carbon for sure. No carbon, no hydrogen on it. Singlet. Ta-da. Yeah. Carbon number 1 though. Carbon number 1 got 2 hydrogen, so a triplet. This guy right here, so there's gonna be triplet, so either here or here. The other CH2 also a triplet, right? But this one next to the oxygen. Well, you remember the chemical shift of carbon next to the oxygen is 60 ppm, right there at 60. Is it that? So carbon number 1 is that peak, a triplet, and carbon number 3 next to the oxygen, 60 ppm, right there. Okay, and the last one, the most shielded one, carbon number 4 right there, 3 hydrogen, a quartet. There we go. All right, that's it. That's simple. Try one more time. So this one, I asked you to sketch. Okay, the off-resonance decouple. So the spin multiplicity, doublet, quartet, triplet. How many hydrogens on it of each signal? So number two right here, no carbon, no hydrogen on it. So that's just singlet. All right. Carbon number 3, there's 1 hydrogen on it, so that's gonna be a doublet. Doublet, right that. Carbon number 4, let's do carbon number 4. So there are 2 carbon number 4 like that. Anyway, each carbon got 3 hydrogen on it, so 4 peaks. 4 peaks we call quartet, right there. All right. And carbon number 1, just like carbon number 4, so 3 hydrogen, so also a quartet. I'll put next to each other like that. Yeah, it's hard to tell which one is more shielded or de-shielded than the other. Okay. All right. Let's try. Now, come up with the structure on the next video. So this is like what I want you to be able to do.